Today we are going to cover section 11.6, polar coordinates. Now in your book 11.6, they cover what we're going to cover in two sections. We're going to divide up 11.6 into two parts. So write down your essential question. How do you convert equations from rectangular form to polar form? Go ahead and paste your cutout or write it down, copy it down, and then example number one. We'll start once you're ready. Go ahead and pause it if you need more time. So the polar coordinate system, instead of having an x and a y, in a plane consists of a point O, where before we called the pole. Before 0, 0, we call the as the origin whenever we have a x and y axis in rectangular graph or a Cartesian graph. Once we move to a polar graph, we have our pole is going to be O. Then we have a ray that's going to be your polar axis. And then you're going to have the rotation, which will be your theta. And r will be the distance from your pole all the way to the point. So before, where we used to have a x and a y, we are going to have an r for the distance between the O and the point P, in this case, and theta, which will be your rotation. So now this is the first time that we actually seen, instead of seeing x and y, we are going to see two other variables, which is your r and your theta. Now, some of you guys might think of why do we actually need this? If we go into decimals, so let's go into decimals. We are going to graph. And now I'm going to click on the graph on the settings, and your graphing calculator has the same options. And now I'm going to click on the grid, it will be a polar graph instead. Now what's nice about the polar graphs, that we can actually write equations that are much more simplistic. And I'm going to type in the equation that I have there. And to type in theta, I'm just going to type in theta. You know, that's an equation of a hyperbola, where the 2 is your eccentricity. So I'm going to label it as letter A. And that'll be your eccentricity. And we know that if it's a 1, it's a parabola. If it's between 0 and 1, it's an ellipse. And if it's greater than 1, it's a hyperbola. Let me just make this from -3 to 3. Makes it a little easier. So therefore, if the value is between 0 and 1, it's an ellipse. If it's 0, it's going to be a circle. And I can just type in 0. If it's a value between 0 and 1, such as 0.5 or 6 or 7 or 8 or 9, that's an ellipse. Once it gets to 1, it's a parabola. So therefore, this is a parabola. 0.5 is an ellipse. 0.9, 0.98 is an ellipse still. But once it goes to 1, it's a parabola. And if we look at the circle, which is, if it's a circle, it will be a 0. Do you guys agree? That means that this does not exist. And then this will be actually the, let me actually leave it there. And if I change this to a 5, then it can change the shape of the graph. And actually this, if I can place this as 1 over 5, that'll be actually the radius of a circle. So therefore, you can actually take additional classes where you can cover polar graphs. And what's nice about polar graphs that we're going to cover on the next section is that we can actually type in 3 sine of theta, and it'll give us nice shapes. And we can type in a 2. So therefore, we can actually talk about different type of shapes. I can type in an A, and then we covered this briefly before. So polar graphs are important because we are able to do a lot more challenging graphs that your x and y axis are not going to allow you to do. But before, just like whenever you get started back in Algebra 1, to graph, you first need to know how to plot points. So we learn to be able to plot your x and then your y. So therefore, in example number 1, that's what we're going to be doing. We are going to be plotting those points before we actually get a chance to graph. I'm going to build my x and y axis. Actually, it's not going to be an x and y axis. We're just going to use it to be able to form our graph. So we are going to do a 5 by 5. And I'm going to use it to be able to place a circle of radius of unit 1. Then I'm going to do a circle of radius of 2. Then I'm going to do a circle of radius of 3. Almost perfect. Radius of 4. And now stop there. I think that's all we need. And that is how we form. So notice that in this case we have 1, 2, 3, 4, 5. That's how we do a polar graph. Now, this will be r. We're going to call that the radius, is the distance from your pole to the actual point, and this will be your angle in radians. So therefore, it'll be radius of 3, and the angle will be 2 pi over 3. So what we're going to do, we are going to first place our point as 1, 2, 3, and then we're going to rotate it to 2 pi over 3. 2 pi over 3 is over here. So that will be the point. But what we actually do first, we actually go to the angle, 2 pi over 3, and then the length is 3, so therefore will be 1, 2, and 3. That'll be the location. So that'll be the process. First, I locate where is the angle 2 pi over 3. Well, I know that this is 1/3, that'll be 2/3, that'll be 3/3. And we usually place 2 dashes. We divide this in 2, and this will be 2 pi over 3. This is 1/3, 2/3, 3/3. And now we are going to go towards that direction 3 units. 1, 2, 3. I'm going to place a ray, even though this is just a point, just to be able to illustrate where it's located. But in reality, we actually just need a point. And that's it. That's all we're doing today. So let's go to the next one. Let's go and build a polar graph. We're going to do a 5 by 5. And we actually don't need the arrows, we just need the circles. So I'm going to do a unit of 1 circle. I'm going to do a circle of unit of 2. Unit circle of 3, 4. And for your homework, I'll have some of those already done for you, so you can just cut and paste, or print, cut and paste. And now in this case, we are going to ignore the negative for now. It's going to be, your angle will be pi over 6. That'll be your angle. And this is your radius. So therefore, I'm going to locate my angle first, which is pi over 6 over here. Now, instead of going towards pi over 6, will be 1, 2. When it's negative, it's going to shoot back. So it'll be 1, 2. So notice that still in the same, it's still towards pi over 6. If it's positive, it goes towards pi over 6. If it's negative, it goes to the opposite direction. It's over here. So if it's positive, it goes towards pi over 6. If it's negative, it's going to shoot backwards. So it's going to go negative 1, negative 2. And notice that in this case, whenever you have your, this is 1, 2, 3, 4, positive 5. And to the left is 1, 2, 3, 4, positive 5 as well. The way that you go negative is that you go backwards. So let's go and graph on the paper. So pi over 6 is, this is 1, 6, 2, 6, 3, 6. So therefore this is pi over 6. But instead of going forward, 1, 2, we're going to go backwards, 1, 2. So therefore will be 1, 2. If we go backwards, that'll be towards this angle here, and it will be negative 1, negative 2. Let's try letter C and D. I'm going to make a polar graph. I'm going to make it 5 by 5. And I'm going to be doing the same for the second one. Now remember that we actually need to use our circles, so a circle of unit 1, circle of unit 2, and I need 4, let me just do one more. That'll be my 5th. As you can see, it doesn't have to be perfect. That was 2.5, so this will be sufficient. So therefore, I'm going to graph is 4 and 5 pi over 4. So first I need to be able to locate where's 5 pi over 4. This is 1 4, 2 fourths, 3 fourths, 4 fourths, 5 fourths. And I'm going to go positive 4, so therefore I'm going to go towards that direction. 1, 2, 3, 4. That's where the angle will be located. So therefore, this is 4 fourths, so therefore 5 fourths will be your angle. Let me go and label it 5 pi over 4. And I'm going to go 4 units towards that angle. 1, 2, 3, 4. If it was negative 4, therefore I'll go to the opposite direction. In this case, it's positive 4, so therefore I'm going to go towards the angle. 1, 2, 3, 4. And that'll be your point. On the next one, this is your R, and this is your theta. So your radius will be 2.5. Your angle is 1.8. So therefore, you have to remember where's 1.8 located. Remember, 1.8, this is in radians. There's no degree symbol. Sometimes I'll give you a degree symbol, but in this case, it's not. So I know that this is pi. That'll be 3.14. And if you remember your radians, 1 radian is about 57 degrees. It'll be 1 radian. This will be 2 radians. This will be 3 radians. And this will be 3.14. The question is 1.8 before or after? So what do you think? Is it before or after? Correct. It's after. This is pi over 2. Do you guys agree? So what's 3.14 divided by 2? It'll be 1.57. And if you're not too sure, then you can just type in pi over 2. And you convert it to decimal, 1.57. And you should know that measurement at this point. So 1.8 will be after, somewhere around here. We're just going to label this 1.8. And we can actually find the correct degree. But in this case, we're going to do an estimation. It's positive 2.5. Remember, if it's positive 2.5, you go towards the angle. If it's negative, you go to the opposite location, to the opposite direction. In this case, it's positive, so it'll be 1, 2.5. So something that you need to keep in mind, if it's negative, instead of going towards 1 pi over 6, you're going to the opposite. You're running away from pi over 6. Example number 2. Go and copy it down, and then we can start once you're ready. Go and pause it if you need more time. So in this case, I need to be able to plot the following point. So let me make a x and y axis. It's not really an x and y axis, correct? Because in this case, this will be 1, 2, 3, 4, positive 5, positive 1, positive 2, positive 3, positive 4, positive 5. And the same thing. In this case, I'm going to use this to be able to make my unit circle. 2 units. And so it's 4, so I do need to be able to do a few more. One more, that'll be the 5th. So in this case, I need to be able to plot 4 pi over 3. So let's see, 4 comma 3 pi over 4. So this is your r and this is your theta. You can think of r as your radius. On the previous section, we used to call that your resultant, your magnitude. In this case, it's going to be the distance from the pole to the point, which will be 4 units away. 3 pi over 4. 3 pi over 4 is over here. And now it's positive 4. Remember, if it's positive, you go towards 1, 2, 3, 4. Sometimes you might just see one point instead of a ray. Now, I need to be able to find 3 additional polar representations of this point. So therefore, one of them is 4, 3 pi over 4. That is this point here. What's another way that I can write it down? Well, another way that I can write it down, I can think of the angle being on the opposite side, which will be here. And what is the location of the angle? Will be 7 pi over 4, correct? So therefore, my other representation will be um, 7 pi over 4 and 4. Now, be careful. It's not positive 4 because if it's positive 4, 1, 2, 3, 4, you have to kind of, it's going to go to the opposite direction, 1, 2, 3, 4. So therefore, we're going to make that a negative. So your angle is 7 pi over 4, but instead of going forward, you're going to go backwards. So what will be another representation of this same point? Correct. I can just basically just, instead of just going 3 pi over 4, I can go around, all the way around again. So therefore I can add plus 2 pi. So therefore I can add plus 2 pi to the angle. This is 3 power 4, so I'm dealing with fourths. 2 pi will be how many fourths? 8 pi over 4. So therefore I'm going to add, and that gives me 11 pi over 4. Do you remember the name of those two angles? 3 pi over 4 and 11 pi over 4 will be coterminal angles. What's one more? What's another way to be able to represent the same point? So we got the original one, two more, and what is the third one? Right, we can just go backwards. So therefore, if we go backwards, this will be 4 fourths, so it'll be negative 5 fourths. And we're going towards it, so that'll be positive 4. And then if you need another one, we can actually just, another way of representing 7 power 4 will be negative power 4. And then instead of going forward, we're going to go backwards. So it'll be negative 4. And there's actually an infinite number because you can always add 2 pi and 2 pi and 2 pi and end up in the same location. Now in this case, you just need 3 more, but then this will be the 4th. Go and copy it down, and then we can start once you're ready. So in this case, we have a specific point. We're going to call that point P. Now, in this case, this is a polar graph, where we have your angle and your distance between your pole and the actual point. If we translate it back into an x and y axis, into a rectangular form, this will be your y, and this will be your x. So therefore, if I'm looking for x and need to use the angle, so x will be your adjacent over hypotenuse. So therefore will be the cosine of the angle will be equal to x over your hypotenuse, which is r. If you multiply both sides by r to solve for x, the r's cancel. So therefore x will be equal to the r cosine of theta. And that is your equation here. Now, if we're actually looking for y, this is your angle, so this will be your opposite over hypotenuse. So we'll be using the sine of theta is equal to your opposite over your r. Multiply both sides by r once again. Your r's cancel, so therefore we have y equals r sine of theta. And now if we're actually looking for the angle, your angle is y over x, so it'll be your tangent of theta will be y over x. And once again, because this is a right triangle, we can use a Pythagorean theorem to be r squared is equal to x squared plus y squared. So therefore, those four formulas that you guys know from your previous sections that we're going to use once again. But now we are going to be able to convert a point from rectangular to polar and from polar to rectangular. So now what we need to be able to have where we have r in theta, I need to be able to write it in rectangular coordinates. So I need to convert it as a x and y point. So therefore, to find the x, I'm going to use this equation. So x equals r, which is 4, and the cosine of theta, which is 3 pi over 4. Now, you guys should know that your cosine of 3 pi over 4 will be, what is the cosine of 3 pi over 4? So remember that you can just make a quick x and y axis. 3 pi over 4 is over here. Your cosine and your sine have the same value, but this is going to be negative square of 2 over 2. You simplify, so it gives you x equals negative 2 square root of 2. Now to be able to find your y value, I'm going to use my r, which is 4. By itself, cosine will be my sine, because my y value will be 3 pi over 4. Your y value will be square root of 2 over 2, and that will be positive because it's going up. So therefore, y value will be 2 square root of 2. So therefore, that is the rectangular form. This is your polar form. And both of them are exactly in the same location. Now, one of the key things that you have to remember is that this is only a point. When we graphed it as a ray, this is the same version as this, where it's only a point. So try letter B and see what you get. And then we can continue. Excellent. So in this case, we have, to find your x value will be x equals r, and that'll be your cosine of 3 pi over 2. Cosine of 3 pi over 2 will be 0. So therefore, x is 0. And to find your y value will be 2, the sine of 3 pi over 2. Sine of 3 pi over 2 will be negative 1. So y is equal to negative 2. And from there, we're going to rewrite it as x and y. So it'll be 0, your x, your y will be negative 2, and that'll be your final answer. Where this is r, and this is theta, this is x, this is y. That is on the same location. And if I take the time to graph it very quickly, let's squeeze it in there. Notice that this is 0 and negative 2. That's the location of this point. And this, the rotation is your angle is 3 pi over 2. And r is the distance from your pole to the point, which is 1, 2. So therefore it matches. So now let's do the opposite operation. Now we are going to convert from rectangular to polar. Go ahead and copy it down, and then we can start once you are ready. So where this is your x and your y, go ahead and pause it if you need more time. Now we are going to have a point where we're going to have r in theta. So therefore, how do I find r? Let's go and find r first. To find r will be r squared equals x squared plus y squared. Before you saw as that r equals the square root of x squared plus y squared. Same thing. Where x will be negative 2 and y will be -2 as well. So therefore r squared equal to 4 plus 4, r squared is equal to 8, r equal to the square of 8, r equals 2 square of 2. Now remember that we do have a plus or minus, but because r, the definition of r is the distance, we only keep in the positive version of it. Now to find theta, I need to be able to use my other formula, which is my tangent. So therefore the tangent of theta equals y over x, which is -2 over -2. So therefore the tangent of theta will be +1. So what is the angle? Now one of the things that you have to be careful is that whenever you are looking for your angle, using same thing that we covered on the last section, tangent of an angle is equal to 1. So it's positive. So therefore it has to be either quadrant number 1 or quadrant number 3. And it's 1, so therefore it's either pi over 4 or 5 pi over 4. So your angle will either be pi over 4 or 5 pi over 4. Which one is it? So we're just going to be able to plot this point. It's -2, -2, -2, -2. So therefore it will be 5 pi over 4. So try letter B. See what you get, and then we can compare our answers. Go ahead and make, let's see, we need to go and pause it if you need more time, and then we can start once you're ready. I need to find two things. I need to be able to find R, and I need to find theta. So let's go and find R first. Because this is your X and this is your Y. I need to convert it to polar form. So this will be your R, and this will be your theta. So to find R will be X squared plus Y squared. So it'll be -1 squared plus 3 squared plus 1 plus 9, r squared equals to 10, r equals to the square of 10. We can convert it to a decimal, but in this case we want an exact answer, so it'll be square root of 10. Now to be able to find your theta, we're going to use the tangent of theta will be y over x, which will be 3 over -1. The tangent of theta will be equal to -3. So now I'm going to use my calculator because the tangent of an angle equal to -3, that's not one of the values that we know. I want to make sure that my calculator is on radians, so I'm going to go back and change to radians. So now it's on radians. I'm going to calculate the inverse tangent of -3. And let me place in parentheses just to be safe, that's correct. So therefore, my angle is -1.25. Two decimal places will be great. Now, I want a positive angle. Well, you can actually have a negative angle, but in this case, we're going to stick with positive angles. I'm going to make a quick x and y axis, because I want to be able to determine which is the correct angle. -1.25. So I'm going to go to the opposite place. So backwards. Is it before -2 or after √2? Yeah, it's going to be before, because this will be -1.57. So -1.2. I know that -1 radian is -57, so it'll be a bit more, somewhere around here. So your angle here is -1.25. Now for tangent, you can also have this angle here can also be correct, because if it's negative, it can be either on the fourth quadrant or on the second quadrant. So let's look at your point. It's negative and then passes. So to the left 1 and up 3. So it's actually up there. So what can I do to be able to get the correct angle? I need to be able to add plus pi, plus 180. Now, if this was the angle, you could have left it as negative 1.25, or you can add 2 pi. But because this is the angle, I need to be able to add plus pi to end up with 1.89. So therefore, my actual angle that I need would be 1.89. And this will be your correct answer. So you do need to be able to know whether you need to use your calculator or whether you actually should be able to know what your measurement of the tangent angle is. Remember, for tangent, we know 1, we know 0 undefined. We also know the square of 3 and the square of 3 divided by 3. If it's negative 3, we know that's not a value that we know, so we need to use a calculator and find the correct one. In this case, was 1.89. And the last thing, we need to be able to now convert equations. Go and copy it down, and then we can continue once you're ready. So example number 5. I need to be able to convert these equations to polar. So therefore, do you guys know where's the equation of this? Where's the graph of this equation? So if I go back to my decimals and I type it up, it'll be a line correct. So it'll be 3x plus y equals 5. So I need to be able to find another equation that will have r in theta, that when I graph it, well, that's not it. That's not it. That's not it. That's not it. So what will be the equation here? That when I graph it, it'll be exactly the same as the green one. It'll be also in line. So in order to be able to convert to polar graph, we just need to be able to replace your x with, remember the formulas that we know. Your x equals r cosine of theta. We know your y equals r sine of theta. We also know that r squared equals x squared plus y squared. So those are the three that we are going to use. So therefore, I want to replace my x with, correct, r cosine of theta. And we're going to replace my y with r sine of theta equals 5. Now the challenge will be that whenever we graph it, we need usually have y equals, in this case, I need to be able to solve for r. So let me go and simplify this. R cosine of theta plus r sine of theta equals 5. I need to be able to find a way to be able to leave the r by itself. Now we do have two r's, but they cannot be combined because they're not like terms. If this was r cosine of theta and this was r cosine of theta, then we can have 3 and 1 will be 4 r cosine of theta. But they're not like terms, so therefore what can I do? Correct, I can factor in r. One factor out the r, and what's left behind? We have r times 3 cosine of theta and r times sine of theta, and that will be equal to 5. And now to be able to leave the r by itself, I'm going to divide both sides by 3 cosine of theta plus sine of theta. 3 cosine of theta plus sine of theta. This will cancel out, and I actually just do it in one step. R equals, I know I need to divide, so it'll be 5 over 3 cosine of theta plus sine of theta. So therefore, if we did it correctly, if I type in this 5, and you should be typing this in your, if you have a computer in front of you will be great. And notice that now they are the same. So therefore that is correct. And this two are equivalent. B. I can replace r x with r cosine, and I can replace y with r sine, but we know that x squared plus y squared is equal to r squared. So I'm going to make a quick replacement, r squared equal to 9. I need to be able to leave the r by itself once again, so therefore I'm going to take the square root on both sides. So r equals 3, and of course we do have the plus or minus, but because we're dealing with r is a distance, we're going to keep it as positive. And let's see if it's correct. So we all know the first equation, x squared plus y squared equals to 9 is a circle. Therefore, r equals to 3 should also be a circle, and it is. Basically, we're just collecting all the points that are 3 units away from the pole. And that's our circle. So therefore, this is correct. Now, what's a little more challenging is whenever we are converting from polar to rectangular. Go ahead and write it down, and then we can continue on the last example for today. A, B, and C. We have one more. They get a little more challenging. So now let's write down the equations that we know, the substitutions that we have. We know that x equals r cosine of theta, so we must have a cosine. Y equals r sine of theta, we must have a sine, or r squared equals x squared plus y squared. So therefore, in this case I have secant, so I'm going to rewrite secant as a cosine. We know the secant is a reciprocal of cosine, so I can rewrite this as r equals 1 over cosine of theta. Now, one of the key things that you have to keep in mind is that you always, if you have a cosine, you always need to have an r right next to it in order to make the replacement. You don't want to divide by r on both sides and replace cosine with x over r. You can still process it and get the correct answer, but it might be a little more tedious. I'm going to place this over 1, and I'm just going to cross multiply. So r cosine equals 1. Someone can just multiply both sides by cosine of theta, which is fine. And now I can replace r cosine, because the cosine has an r right next to it. I can replace it with x. And that is key thing to remember, that if you have a cosine, you must have an r next to it in order to make the replacement. So according to this, those two expressions are equal. So if I graph them on Desmos, they should be overlapping. So let's try the first one, r equal to the secant of theta. That's a line. And x equals to 1. That is correct. Both of them are vertical line. Letter B. One of the key things that you have to remember is that in this case we do see a cosine, but you must have an r right next to it. We can cross multiply both sides again, since we have the cosine on the denominator. I'm going to multiply both sides by 1 minus cosine of theta, 1 minus cosine of theta, or you can think about cross multiplying as well, whichever you prefer. That will cancel out. So therefore I have, let me multiply it out. We have r times 1 gives me r times negative cosine is negative r cosine of theta. Now, one of the things that we have to be careful is that we are very tempted to factor out the r from here. And you can, But that might not drive you because you do need the r, the cosine next to an r, and we have that already. So do not factor an r. From there, I can replace my negative r cosine of theta with negative x. And r, I'm going to replace it with, I'm going to take the square root on both sides. So I know that r equals the square root of x squared plus y squared by the square root equals 1. Now, I need to be able to solve this in a way that it's familiar to me. I see a square root in there. So what I'm going to do, I'm going to move my x to the right. It becomes a positive. So therefore now I have the square root of x squared plus y squared equals, that'll be x plus 1. I'm going to get rid of the square root by square on both sides. The square root and the square cancel, so therefore I have x squared plus y squared equals. I'm going to multiply this out. Remember that whenever you multiply it out, we have x plus 1 multiplied by x plus 1 gives me x squared plus x plus x plus 1. So this gives me x squared plus 2x plus 1. And most of you guys can do it without expanding it. And now I can actually cancel my x squared, so minus x squared on both sides. They both cancel. So therefore I have y squared equals 2x plus 1. So what type of equation is that? Correct. That's a ellipse. This is an ellipse. That's a parabola. Only one of them is being squared, so therefore that's a parabola. Now remember that your formula for your parabola, your y squared is on the left. I need to be able to factor a 2, and that was, if you go back to your section from parabolas, you'll see the notation. My factor, or the notation of the formula, factor 2, 2 times x, and 2 times 1 half gives you the 1. And that is the correct equation for a parabola. And if we graph it, now if you're not too sure when you're doing your homework, if you want to go in and graph it first so you have an idea of what your equation should be, that's fine. Because at the beginning, you're not really sure what the equations will look like by this formula. But that's your problem. If I graph the second one that I got, y squared equals 2x plus 1 over 2. Notice that they overlap, so therefore they are the same graph. And the last example for today. Something that looks pretty easy, but you kind of have to get used to, as you're doing your homework, just refer back to those 3 examples. When you do your homework, refer back to those 3 examples so you can guide yourselves to see how can I rewrite it in rectangular form. One of the key things that you need to remember is that you must have, if you have cosine, you must have an r next to it. So what's one way that, and there's more than one way to do this. So if I need an r in here, I'm basically just going to multiply both sides by r. So that gives me r squared equals 2r cosine of theta. I'm going to replace my r cosine of theta with an x, so it'll be 2x, and r squared will be x squared plus y squared. Now at this point, you should be able to know what type of equation this is. What do you think? Is this a circle, parabola, ellipse, or hyperbola? Correct, it's a circle. They both are squares. So therefore, I just need you to be able to rewrite it in the correct form. I'm going to move my 2x to the left, becomes a negative. Now I need to complete the square, so I'm going to leave some space in here to complete the square. So I can find my h and k. And what I do on one side, I need to do to the other side. Do you guys remember how to complete the square? You take half and then square. What's half of negative 2? Negative 1. Negative 1 times negative 1 is positive 1. I'm going to factor this out. When I factor this out, this should be the same because now it's a perfect square trinomial. Factors of x squared will be x and x. Factors of 1 will be 1 and 1, and they both should be negative. They will always be the same, so it'll be x minus 1 squared plus y squared. And now it's a circle with the radius of, with the center of 0, 1, radius of 1. And let's graph it to confirm. So if I graph the first one, which is r equals 2 cosine of theta, and I graph the second one, x minus 1 to the power of 2, to the power of 2 plus y squared equals 1. Notice that they overlap, which means that they are equivalent. So that is the lesson for today. Just make sure that you guys refer back to this page as you guys are working through your homework, and that should be very helpful. Email me if you have any questions. Have a great day.